So today we are going to discuss about nomenclature. Nomenclature of complex compounds. See, first, whatever the compound, we must write first positive ion. So first positive ion, next negative ion. So we are discussing their names. Suppose in the same manner, suppose you take example K4 FeCN taken 6. So here potassium is positive. So this is 4 negatives. So this is a plus 1. So in the given complex compound, first you tell about positive cation. So that's why it is started with potassium. So next it will go. This is the first point. Next. Second point. In the complex sphere, so which one you called as a complex sphere? Metal is surrounded with some number of ligands. This is a complex sphere. In the complex sphere, first we discuss about ligands. So next, discuss about metals. So in the explanation of complex spheres, first complex sphere contains metal is there, ligand is there. First we are discussing about ligand. Next, in this ligands, so ligand representation. So in ligands representation, you take A. So the ligands are represented in alphabetical order. Ligands are represented according to alphabetical order. So English letters based on that. Say suppose you take K4 FeCl Br, suppose Cl2 Br2 Cn taken twice. Is there? First it is started with what? Potassium. So we are started with potassium is over, positive. Next negative. Negative is the complex sphere. Complex sphere means it is ligands are different. It is chlorine C is there, bromine is B, cyanide is C. So chlorine it is a CH, cyanide. So you write CY. So in this also, first one you take alphabetical order, negative ligands. Next point, negative ligands represents, so end of its name you write as O. Next, positive ligands. Positive ligands, the end you write as IUM with a suffix. Next, neutral ligands. So neutral ligands you represent with original names. In this, two important, one is that water. Water you called as aqua. Next, NH3 you write as amine. AMMINE. So double M, you remember that one. Next, If similar ligands, more than one, if similar ligands are observed more than one, so then if two are there, if two ligands similar is there, you can write as a di. If three similar ligands are there, you write as a tri. So if similar ligands are four, you write as a tetra, and so on. See, if polydentate ligands, observed more than one. See, polydentate ligand means what? Bidentate, tridentate, tetradentate, like that. Anything is came means. So if two are there, then this is called as a bis, indicated. Three are there, it is a tris. If four is there, so you write as a tetrakis. So like that you can extend. If monodentates are more than one, bi, tri, tetra. If polydentate ligands more than one, two is a bis, three is a tris, and like this. Next, E. If complex contains bridged ligand, so that ligand name before the name of ligand, you represent mu. So mu symbol you mention before the name. The mu indicates that is the bridged ligand. Bridged ligand means in between the two metals the ligand is existed. If the given complex contains ambidentate ligands, so if the given complex contains ambidentate ligand, means what? So the ligand has more than one donor capacity, but any one of the atom only donating pair of electrons. For that, so which element is donated? Which element is donated lone pair to the metal? That element symbol, must be represented. So example, if Cn minus, so it is minus is present on nitrogen, so you write as cyano-C. Suppose Cn minus like this. So now who is donor? Carbon is donor. So that's why you called as cyano. Here N. N is donor means cyano-N. Carbon is donor means cyano-C. Next, NO2 minus. So you write as nitro-N. See, this is, you write as isocyano also. So this is nitro-N means you write as direct nitro. So you are mentioned nitro means N is the donor. Suppose ONO minus. ONO minus is there. You can write as nitro O. Otherwise, nitrito. This is. Suppose SCN minus. So you called as thiocyaneto. Thiocyaneto S. So otherwise thiocyaneto N, thiocyaneto C. So who is donated, that you must write. Suppose if you see that examples what we discussed about ligands. See, suppose you take K4 FeCl2 Br2 Cn taken twice. So first we started with a positive potassium. Next we are enter into complex sphere. Complex sphere contains metallo-ligands. So first we discuss about ligands. So it is started with C. It is started with B. It is started with C. So it is CH. It is what? CY. So that's why you write as 2 chlorines are there. So you write as dichloro, comma. Next, dicyano. See, negative ligands. Negative ligands are ended with O. Next, dibromo. So after that, next extension. So first of all, you must write positive. Next, complex sphere we are entering means you must concentrate on ligands. After completion of ligands, we think about the metal. So next, fourth point. After the representation of ligands, the metal is represented. The metal is represented. So in what way the metal is represented means, so here also some important points. A. If complex sphere contains positive charge, if complex contains a positive charge, otherwise a neutral charge, so there is no charge, then this metal, so you represented as original name only. So original name of the metal only we can represent. See, suppose the given complex sphere contains negative charge. The metal, this metal name added with ATE. So the metal, upon complex sphere contains negative charges there means you can write as metal 8. Point. Next, we see the example. Now you take, there is K4 FeCN taken 6. So you can write potassium plus complex sphere. So you write hexacyano plus. So this is what? Negative. Here 1 positive, 4 positive, so 4 negative. So complex sphere contains negative charge. Metal you write as metal 8. So you write as ferrate plus. Next extension. Next, fifth point. After representation of metal, the metal oxidation state, must be represented in brackets with Roman letters. So next, so here, so what happens? So potassium hexacyanoferrate. What is the oxidation state? So here, this complex contains 4 negatives. Every cyanide has 1 negative. 6 negatives. In 6 negatives, 4 already top. So that's why remaining is what? 2. So that's why, so you can write as ferrate 2. So the name is completed. See, if given complex contains there is no that is in the positive, otherwise negative charges. Suppose the given complex sphere contains any charges on the top, so that is you can the last its name is ended with ion. Suppose you take FeCN taken 6 minus 3. So this is, so first of all what complex sphere only given. So that's why you write as a hexacyano plus metal you write. Metal negative charge, metallate. So you write as a ferrate. Next, in the brackets, oxidation state we must write. So here minus 1, 6 negatives, 3 are top. So that's why it is plus 3. So you write in the oxidation state in Roman letters in brackets. Next, that is given as a charged. So that's why you write as ion. Then only that is completed. That. Next, suppose if any charge is not there. Suppose you take Fe. Nickel. Suppose you take nickel CO taken 4 like this. So here neutral. Suppose this one you called as first metal ligands. So you write as a first ligands tetra carbonyl. So tetra carbonyl. See, that is what neutral only. So that's why you write as nickel. Nickel oxidation state is 0 because of carbon monoxide 0. Oxidation 0 means you put in brackets as a 0. See, if the given complex, if a given complex contains geometrical isomerism, so before you must write either cis or trans. So which geometry is there? You find out that one and you mention cis and trans before its name. Suppose if the given complex contains stereoisomerism. So stereoisomerism means, so you can write if dextro compound is there. So dextro compound means either you write D or plus. If the given compound contains levorotatory, so then you can write a small l or minus. So that also you can write. See, this name, potassium. Next, oxalato. So oxalato is what? 3 members are there. So that is what? Tris. So tris oxalato. Next, negative charge. Here 3 positives outside, 3 negatives on top. So that's why you called as chromate. So chromate. Oxalate means minus 2. 3 2s are 6. Already 3 are there. So that's why it is plus 3. So chromate 3. That. Next, this is what Nessler's reagent. K2HgI4. So here, potassium. Tetraido. Mercury. Outside plus 2, here minus 2. So that is mercurate. Next, in 4 negatives inside, outside 2 negatives. So it is what? Plus 2. So mercurate 2. Next, this one, sodium plus 1 minus 1. So dicyano plus 2 negatives, top 1. So that is what? Plus 1. So that is what? Negative charge. So that is silverate or argentate 1. Next here, complex sphere only given. So tetracyano. So tetracyano, nickel 8. Nickel 8, 4 negatives, so 2 are there. So 2. Next what? Ion is given. So compulsory you end with ion. Next here, potassium. Next C and nitrosyl. So N means nitrosyl. So pentacyano. Next here, nitrosyl. Next here 3 positives. Here 5 negatives. So here what? 3 positives means here 3 negatives. So here in 5, 3 are there. So iron is 2. Complex sphere contains negative. So that's why you write ferrate. So 2. So nitrosyl is what? 0. Oxidation state. See here. So complex sphere is positive. First complex sphere, next that one. So here hexaamine. So hexaamine, positive only. So here 4 negatives. 4 negatives means here 4 positives. Ammonia 0. So that's why platinum. Platinum 4. Next to chloride. So hexaamine, platinum 4, chloride. So this complex sphere is positive. This is plus 1, this is minus 1. Chlorine is minus 1, 0, 0. So here you write alphabetical order. So that means first amine. So tetraamine. So tetraamine, aqua, chloro, otherwise chlorido. So no problem. So chlorido. Next, what will be the charge? Say minus 1. Because of minus 1 it gets plus 1. Again plus 1. So you are getting 2. So cobalt. So cobalt 2 plus ended with chloride. Then next here complex sphere. So ethylene diamine. Ethylene diamine is what? Bidentate. So that's why you write bis. Ethylene diamine. So bis ethylene diamine. So here minus 2, here plus 2. So copper. So copper 2 sulfate. First positive, next negative. Next here. So tetra aqua. So tetra aqua. Dichloro. Otherwise dichlorido. Next here 2 negatives are there. Minus 1. 2 negatives means plus 2. Top 1 is there. So that's why chromium 3. So oxidation state is 3. But this is what charged ion is given. So you must end it with ion. Next here aqua. So tetra aqua. Next oxalato. Next if charge you see means here minus 2. So here complexes are 2. So that's why every complex contains what? Here plus 1, another plus 1. So two negative charges are taken by two complexes. So every complex has plus 1. Inside every complex minus 2. So here minus 2 means 1, you are getting plus 2 and plus 1. So you are getting iron, iron 3, or ferrous. You write it 3. That better to ferrous and ferric, iron is the better one. So sulfate. That. Next here. So this is a triphenylphosphine. So but 3 members are there. So triphenyl. So this is complicated. So that's why this is indicated with tris also. So tris triphenylphosphine. Triphenylphosphine. So tris triphenylphosphine rhodium. This is minus 1. So that's why plus 1. So this is what? Neutral molecule. So plus 1 coming to rhodium. So that's why rhodium 1. Last chlorine is there with the chloride. Here. So this is pentacarbonyl. So pentacarbonyl iron. Oxidation state 0. That is, if this is 0 oxidation state, that one. Next, ammonia 0, NO2 minus 1. So 3 negatives means the oxidation state become as a plus 3. So that's why here amine, triamine plus tri. So trinitro. Next, cobalt. Oxidation state is 3. Next, glycinato. Glycinato is minus 1. So this is bidentate ligand. Bidentate ligand more than 1 is there. So that's why bis, glycinato. So copper 2. So 2 net. Next, DMG, dimethyl glyoxamato, that is minus 1. So here dimethyl glyoxamato also bidentate ligand. So that's why you can write bis, dimethyl glyoxamato, nickel. So minus 1, 2 negatives means that gets 2 positives. Nickel 2. Here, 2 complexes pair. Such type of names are there asking means one basic point we have. So coordination number. So coordination number equal to 2 into oxidation state. So this is very fundamental. Majority 99% everyone is following that only. So here, so 6 negatives are there. 6 negatives means that 6 ligands are there. Coordination number 6. What about oxidation state? 2 into 3. So that's why it is plus 3. So it is plus 3 means 3 are neutralizes. So that's why minus 3 is coming. This complex minus 3 means this complex is plus 3. So first you write positive only. So first you write this one. So that is what? Hexaamine. So hexaamine chromium. So chromium 3. Next, plus. You come to negative charge. So hexacyano. Next, cobalt negative charge. So you write cobaltate. Next, oxidation state 3. So in the given complex, first positive, next negative. So you come to here. So here 4 number is there. Coordination number 4 means half of the oxidation state. So that's why it is plus 2. Here 4 negatives are there. 4 negatives, 2 are neutralizes. Remaining 2 are on the top. This complex is minus 2 means this complex become as plus 2. Ammonia is 0. So that's why plus 2 is going to platinum only. First we write about positive. So that is tetraamine. So tetraamine platinum 2. Next, you come to this complex. So tetra, chloro, otherwise chlorido. Next, copper negative charge. So you write cuprate. Next, 2. So you write cuprate 2. Next, in this, here also, first of all, this is 0. So here minus 1. So here 4 are there. So oxidation state half of the 4. So that's why it is plus 2. So here 4 negatives, it is neutralizes 2 only. Remaining 2 negative charges are there. This complex 2 negatives means this complex is plus 2. First you explain about this one. So that is tetrapyridine. Py means pyridine. Tetrapyridine platinum 2. Next, negative complex. So here complexes were first ligands. So tetrachlorido. Next, platinum complex contains a negative charge. So that's why you write platinate. Next charge is 2. So platinate 2. Suppose this bridged ligand complexes they are given. So that means you can take, so sulfate is minus 2. 2 negatives. So 2 are there. So minus 4. Minus 4 means you will get plus 4. So this is the amido. So minus 1. Minus 1. So 4 positives on top. Because of these 2 negatives, you are getting 2 positives inside. 2 positives, so 4 positives. Total 6. So that means this cobalt is a 3 oxidation state. This is a 3. So this individually you write everywhere. So it is 2 members are there. So you write as bis ethylene diamine. Cobalt 3. So bridged ligand. So you write as mu amido, comma mu hydroxo. So mu amido, mu hydroxo. Next one is what? Bis ethylene diamine. Bis ethylene diamine. Next, cobalt. This is also 3 plus outside sulfate. The name. So first you find out the oxidation states. Next you tell about this. These two you write as mu symbol because of bridged ligands. Next you explain this one, and last sulfate. So here also, here sulfates are 2. So that is why it is 4. Because of minus 1. Total is what? 6 positives. So here also 3. Here also 3. So now, so one by one you can explain. So this is what? Tetra aqua. So tetra aqua iron. Because of complex contains positive only. So iron 3. Next, mu. 2 are same only. So that's why you write mu dihydroxo. Negative. Next, tetra aqua. Next, iron 3. Next, positive is over. Now what? Negative. So it is a sulfate.